Hello, there is Impossible Creations, and this is introduction tutorial video in which I will explain how procedural generation grid is working and how you can find solutions in different design cases. This video is dedicated for beginners, and after watching this tutorial series, you can go and watch the older tutorials, since these old tutorials are explaining much more about PGG system, but in less beginner-friendly perspective. So don't think that the older tutorials are outdated. They are up to date, but a bit more difficult. Okay, so let's begin. To start working with PGG after installing it in your project, go to Window, Impossible Creations, Field Designer. Let's dock the window, it will be more comfortable using it this way. Hit New button to create field setup on which we will be working in this tutorial. I will call it Tutorial 1 Field Setup. Okay, it's renamed. I see that the scene view is rotated in the wrong way, so let's quickly switch from beginner to the advanced mode. And here we can use the center button. Switch back to beginner, and here we have clear view and we can start working on a field setup. Let's add field modifier to spawn something on a grid. Field modifier window appeared, so let's dock it on the right. It's important to see both Field Designer window and Field Modifier window in the same moment. First thing we will do will be spawning floor tiles, so let's call this modifier floor. In Designer window you can see that this Field Modifier is contained by our field setup, and always you can select it to work with it in a window on the right. Finally, let's generate something. I will find prefab of the floor and put it inside the modifier prefabs list. So it's somewhere in here. Okay, let's drag and drop it. So that's how this prefab looks on a scene. And now we will instantiate it on a grid. Let's add spawner for this prefab here. And there we have it. It's generated on every cell with 0 position and rotation. If your floor tile would be bigger or smaller, you can adjust it with grid single cell size in the designer window. Now let's talk how the grid logics works. Well, the floor 1 spawner is running its rules on every cell, checking one by one. Here we don't have any rule yet, so the tiles are just created without any objections. I will add example rule to show how it works, and I think check cell neighbors node will be best to introduce you. With this node we can check state of neighbor cell in relation to executed cell. Let's say we want to spawn floor only on the left side of the grid. So let's basically check if cell on the left is out of the grid bounds. And there we have it. Now let me explain what is going on. The rule is trying to get cell on the left, then checking if it's not contained in the grid. And it is not contained, so rule allows prefab to spawn. And the next cell runs rule, which is checking cell on its left, but this cell is in grid and rule not allows to spawn prefab. And then same thing repeated on every cell. Now next example. Let's spawn floor only on the top left corner. So we check if cell on the left and in the front is out of grid. And there you go. What happened here? There's explanation. Only this cell has out-of-bounds neighbors in front and on the left. All other cells are not meeting this criteria. Now if you would like to spawn floor on each corner, you would need to do neighbor checks like this, and this. You could go duplicate spawner and prepare one spawner for each corner like this. But it's time consuming and there are much faster solutions. Let me show you a few of them. So let's remove these spawners. And we can use rotor check feature of the check cell neighbors node to do additional checks with 90° steps with configurable step rotation and configurable initial rotation for quick adjustments. What is very important for me to mention now is negate button. It will reverse logics of the rule. The hashtag button does it. And there you have inversion result. You will use it very often, so prepare to get used with it. Now let's remove this rule node And let me show you a node which is dedicated for placing floors. It's under Quick Solutions, Floor Placer. With this rule, you can quickly adjust rotation, position, and spawn restrictions for the floor tiles. If you need specific tiles in the middle of the room, or dirty moss tiles under the walls, you can easily set it up with this node, simply by checking its spawning modes. And the same as with other nodes, again you can use the negate rule feature. But for this tutorial, let's just use default values and let's do something more interesting. Let's just quickly rename this spawner to floor base to not get lost later. Okay. There we have some extra prefabs of broken floor tiles. Let's add them to the field modifier. Let's add spawner for the broken tiles. And we need to replace clean tile with broken one. With these two spawners, there are generated two floor objects which are overlapping each other. So when we spawn the broken one, let's remove the clean one. And we will do it with remove spawn node. So if there is scheduled some spawn, it will be removed. Let's disable gizmos to see it better. Let's switch on and off the spawner to compare results. And now it's important to use tags to avoid removing unwanted objects from cells. So let's just add if tag to the clean floor and allow removing only if tagged objects here. Thanks to that, we can avoid troubles in the future, like removing some furniture instead of a clean floor tile. Okay, now you probably think, why are we using just one broken tile, when we have there many variants of them available? Well, we can set spawner to generate random prefabs from the list, and that's how it works. But let's say we want to have just few broken tiles and more clean tiles, so we need more control to achieve it. Let's choose one prefab and toggle this. This toggle enables multiple prefab selectors, so we can choose which prefabs should be randomly selected for spawning with this spawner. And there it is, so we selected just broken tiles. Okay, so let's limit broken tiles count, and we will do it with spawn probability node. Now every cell will roll dice to be allowed to spawn or not. But you see on the preview that it's flickering every move of the slider and it's hard to read. That's because each time there is different random seed. Let's quickly switch to advanced mode, set fixed seed, and preview the rule clearer. Now it's much easier to understand what's going on. When value is lower, there is more clean tiles, and when value is bigger, then there is more broken tiles. And as always, you can switch the node to compare results. Right, now let's restore the random seed, so let's go to advanced mode, change seed to 0 and switch back to beginner. Now let's call this spawner broken floor for clarity. And that's all for this field modification. Next one will focus on some simple props. So let's add new modifier, call it props, and let's find some prefabs we will use with it. Let's add this planks debris models to field mode list, another one, and one more. Okay, let's add spawner and check result, and let's switch to random spawning. Now let's randomize it more, and let's do easy start with well-known spawning probability. Let's adjust the value, and I think this will be okay. Now let's add a random rotation with rotate node and apply random rotation to 360 degrees. Let me quickly switch to advanced mode and set fixed seed to see randomization more clearly. And you can preview it with more clarity what values are applied to objects. Okay, let's restore random seed per preview, so we can quickly check different cases. Now let me scale down spawned models a bit. And let's do also little scale randomization, but just a little. Now let's say we don't want debris to be spawned next to each other. To prevent that, we can check distance between each debris and disallow spawning them when they are too near to each other. We will use debris tag to identify each other, and then use distance to other cell rule, apply tag, adjust distance, and it works. Okay, that's all for the debris. Now let's try to add cupboard on the edges of a grid. Let's hit generate. And oh, there is randomly used cupboard. Let's disable random spawning for debris and use selector to just use the debris prefabs. Now we can add spawner for the cupboard. And here it is. Now it's worth to mention that spawned prefabs are inheriting rotations of last spawned object in a cell by default. If you don't want this, you can unfold more options here and disable it here. Let's place cupboards on the edge of grid. And in this tutorial, we will use check cell neighbor node for this. So let's check if some cell is out of grid. Adjust model rotation and do rotor 90 degrees step checks. Let's separate cupboards in the same way we did a minute ago for debris. So using tag and distance rule. Right here our furniture tag, and 3 cells separation will be enough. Now we need to adjust cupboards positions. And it's important to have idea what is world space offset and what is local space offset. World space will move all cupboards the same way, but local space will move them accordingly to their rotations. So, with local space offset, we can back them up to the grid edge. Now we will prevent spawning debris in cupboard position. So let's quickly find fixed seed with such situation. And there we have it. And to prevent spawning the debris, we can use rule called if cell contains tag. And here we can write cupboard tag and negate it. So it should spawn in cells different than cupboard cell. But it seems it's not working. And that's because debris don't know about cupboard existence. Debris spawner is first in execution order. So, cell is not containing information about cupboard spawn yet. Now, if we change spawner's order, debris spawner detects cupboard, and rule works correctly. And it's very important to keep in mind that the order is crucial when working with PGG system. And these order logics are applied the same way with field modification list. For example, now Flow don't know about our props existence. Okay, if that's clear, let's prevent spawning broken tiles under the cupboard. So let's change execution order for the floor to know about props. Let's add if cell contains tag rule again, and write here cupboard tag and negate it. So no broken tile is allowed to spawn under cupboard cell. Alright, it works. So let's restore random seed. And one more thing you could notice now is not randomized placement for the cupboards. That's because we are using distance rule and cells are always checked in the same order. So going one by one, and the distance rule is met, so another one, and resulting in the same pattern. We can fix it by switching spawner cell check order to be random. So cells, instead to be checked one after another, will be executed with a random pattern. And now it's randomized in a more unique way. Alright, Now one before last modificator for this tutorial. And it will be walls. Let's select it. Let's find the wall prefab to start working with this field mode. Let's enter this directory and it's here. Add spawner. And first I will use check cell neighbors rule to explain some extra stuff. As before, we will check if cell on a side is out of grid, do some local space offset to align wall model to the grid edge. There I will use cells instead of units to move wall by half of the cell size. Okay, now when it's set, we can enable 90 degrees rotor check to frame whole grid. But what's going on? There are walls lacking on the edges. Why? That's because edge cells requires two wall spawns, one on the left and one on the back. But spawner is called only once on each cell, so it can't spawn two walls. One of the solutions is using multiple spawners, each for one side of a grid. Here I will just duplicate spawners and adjust checked cell and rotations. And it's solved. But it can be time consuming to do changes with so many spawners, so we can remove all of these spawners and rules and replace it with other node which can be found under quick solutions, and it's called wall placer. Spawn on each side toggle is solving our problem with the lacking walls on the edges. Now let's adjust rotation and offsets to make walls fit the grid, and there you go. This node also provides logics for placing 45 and 90 degrees wall curves, as well as corner fillers, which can save a lot of time when designing procedural architecture generators. To finalize this field design, we will add some lighting to this dungeon room. Let's add last modificator for this tutorial, call it lighting. And this time we will attach torch to the wall coordinates, meaning position and rotation plus some offsets. And to do it we will use node getCoordinates. This node requires tag of target spawn to attach with it, so we write here wall. Let's tag our wall spawner with wall tag. Now select lighting modificator. Okay, and it seems that torches are rotated 180 degrees from target rotation. We will fix it in a while. But first let's use features of this node and let's automatically disable spawning torch if there is no wall. Now adjust rotation. And now the position offsets. Do some perfect wall fit distance. Now torches are spawned on every wall, but we don't want to spawn the torches in a cupboard position, so let's prevent it using if cell contains tag rule. Right here cupboard tag and negate effect, and it's fixed. And let's add torches separation with a cell distance rule. Use random order, and here it is. Okay, let's say this field setup is ready. Now we can clear it, go to scene, add grid painter, assign our field setup, enable gizmos, and freely paint any shape of dungeon room. It can be tunnels, big rooms, small rooms, any type. Then if you want to generate procedural shapes of the rooms and whole dungeon structures, you need to learn about Field Planner. There are tutorials for it, and also Field Planner is constantly developed right now. And for final polishes, you can switch all models to be combined into single meshes per material. It can really help you optimizing the generated structures. You can switch combining individually for each field modifier or field spawner, but to enable it on every spawner, you can unfold the field setup file, find modifiers pack, and here you can switch combine all and set static. And it just works. Now if you go to hierarchy, you will find initial game objects, but just for colliders. But meshes, you see, are combined, resulting in few draw calls instead of thousands draw calls. And anytime you can disable combining and go back for editing whole generated structure. Another very useful thing for final polishes is auto-generating reflection probes. An option for it you will find here in post events. Let's generate multiple reflection probes and check on the scene how it's generated. So let's go in hierarchy to reflection probes container, and there you have it. That's it for this tutorial. In next parts I will explain adjusting third-party prefabs with PGG, working with doorways and cell commands. I hope this video was helpful for you. If you have questions, feel free to ask in the comment section below. Leave a like, subscribe for more, and thank you for watching. See you next time. Bye bye.